In this video, we're going to have a look at how we can graph the tangent function. So consider we've got a function f of x, and we define f of x as tangent of x. And we're going to do it over a range. So we'll do it over a range of, we'll say 0 and 2 pi radians. Now, have a think back of tangent and the way in which tangent relates to the sine and the cosine function. So you may recall that tangent can be defined as the tangent of x can be defined as the sine of x divided by the cosine of x. And this is really important because the behavior of the sine and the cosine function and their relationship as in the quotient, the behavior of this is going to define what the tangent will look like when we graph it. So simply having a look here, if we know that the tangent is equal to sine over cosine, then we can see when sine is at 0, we're going to expect a value of 0 for tangent. So I'll get my I won't use orange, I'll use purple for tangent. So when sine is 0, we're going to expect tangent to be 0. Similarly, when cosine is 0, so cosine being on the bottom, when cosine is really small, it doesn't matter what the value of sine is, because we're just going to expect the value of tangent to be absolutely huge. So notice the way in which sine and cosine operate. So sine starts at 0 and goes up to 1. Cosine starts at 1 and goes all the way down to 0. So when sine is quite small, cosine's at its maximum, and when sine is at its maximum, cosine's at its minimum. So we're going to see something as very small, and up here, very big. So we might expect it to look something like that. We'll just leave it like that for now. And then let's go down a little, get some more graph visible. So notice that over in this point here, we're expecting it to be very big. But down here, notice that the value of sine is 0 again. And the value of cosine is quite large. So, okay, that's one point. What about the negativity of these values? So notice that sine is positive and cosine is negative. So what we're going to see is something negative down here, because we know this region here, tangent has to be negative. So we might expect the tangent to look something sort of like that behavior. And then going over back up here, so when cosine is 0 and sine is equal to 1, so notice sine's negative and cosine's also negative in this region here. So we're going to expect a positive for this quadrant. So up here we can say it's going to be monumentally huge. So might look something like that. And then finally we've got a positive value of cosine but a negative value of sine. So we're going to be coming back from the negative and going back towards the 0. So something like that. Okay, so here's a rough estimation of what cosine might look like. But again, it's not quite right, because remember, sine and the cosine, they're not linear. So tangent itself isn't going to be linear either. Rather, consider how they're changing. So what we're going to expect is this cosine function, it starts off quite high and then it rapidly, well, it doesn't rapidly, it slowly starts to taper off. And then as the angle gets quite big, so as you hit about, let's say that's pi on 4, it really starts to taper off. Whereas conversely, the sine, it grows quite fast and then it grows slowly. once it hits pi on 4. So what we're going to expect is the sine, it's going to grow quite fast and then slow down, and cosine is going to decrease slowly and then speed up. So what we're going to expect is something like that. So more of a nonlinear shape. And similarly, something like this, and something like that, and then something like that. Alright, so let's clean that up a little. Let's get rid of the original assumptions. Here, here, and here. Not quite. There. So what we can see in purple here, this is a general estimation of what the cosine function would look like if we graphed it. So here we go. So if I want to do this a little bit neater, let's go over to Desmos and see what Desmos, or how Desmos will graph it. So jumping back over here, we've got a sine, so our sine in red, and our cosine in blue, and we want to graph the tangent. So what we can say is that y equals tan of x, and behold, in green, this is our tan, and if we graph it over one period, look at the shape it is. So it's very similar to this purple one here, but of course Desmos is much neater because it is almost exact. So if I zoom out, notice that at pi over 2, tangent zooms off into undefined, positive undefined, and then at pi on 2, going into quadrant 2, it comes back round in the negatives. And then quadrant 3 zooms back off again to positive undefined. And then in quadrant 4, it comes back round again from negative undefined back to 0. So what we see in green here is the behavior, or the graph, of the tangent function.